Welcome to section 13.1. This is the 142nd session of the CISSP exam prep series. In this session, we'll cover how you control access to the things an organization values. We'll answer several questions. What exactly counts as an asset worth protecting? What are the 6 technology asset types you must guard? How do physical controls protect them? How do logical controls protect them? And how does all of this map back to confidentiality, integrity, and availability? Why does this matter beyond the exam? Because access control is the daily work of protecting a business. Imagine a regional credit union. It has customer records, transaction systems, laptops, branch offices, a mobile app, and a print service. Every one of those is an asset, and each needs the right lock. When you can name what you are protecting, you can choose the correct control for it. That skill is what turns a policy into real protection. So what actually counts as an asset? An asset is anything of value the organization needs to defend. Some assets are tangible, meaning you can physically touch them, like a server or a badge reader. Others are intangible, like a customer database or a patented design. People are assets too, but our focus here is on the technology side. Think of it like a warehouse. Some things on the shelves are physical goods, and some are the blueprints that make those goods valuable. What are the 6 technology asset types you must protect? The certification groups them into a clean set. There is information, systems, devices, facilities, applications, and services. Each one is a different surface an attacker might reach through. If you can picture all 6 at once, you can audit any environment and confirm nothing is left uncovered. We'll walk through each one now, so the whole map stays clear in your head. What do we mean by information as an asset? Information is all of an organization's data, wherever it lives. That includes files on servers and laptops, records inside a database, data sitting in the cloud, and even paper in a filing cabinet. Logical controls are what keep unauthorized people away from it. Picture a law firm's case files. Whether they are digital or printed, the goal is the same. Only cleared staff get to read them. What counts as a system worth protecting? A system is any set of components that delivers one or more services. A single file server that hosts shared documents is a system. So is a web server paired with a database to run an online store. You control access to systems through the permissions assigned to user and machine accounts. Think of a system as a working machine on a factory floor. Only trained operators get the keys to run it. What are devices in this context? Devices are the physical computing equipment across the environment. That covers networking gear like routers and switches, storage arrays, servers and desktops, laptops, tablets, phones, and even printers and scanners. Many organizations now let staff connect personally owned phones and tablets. Here is the key point. Even on a personal device, the company data on it is still a company asset. So the phone may belong to the employee, but the sales figures on it belong to the business. What about facilities? Facilities are the physical places the organization owns or rents. That could be a single room, a full building, or an entire campus of buildings. You protect them mainly with physical security controls. Picture a data center. Fences, guards, and locked doors all exist to keep the wrong people from ever reaching the racks inside. Why treat applications as their own asset? Because applications are usually the doorway to your data. By controlling who can open an application, you add another layer of protection around the information behind it. Permissions make this easy, assigned to individual users or to whole groups. Think of an application as the front counter of a bank. Even before anyone touches the vault, the counter decides who gets to make a request at all. What are services and why guard them? Services are the capabilities an organization offers, like printing, network capacity, or end-user support. Access control systems make sure only authorized users can consume them. Imagine a shared print service in a large office. Without controls, anyone could route sensitive documents to any printer. With controls, only the right people reach the right output. So how do you actually protect all these assets? You use 2 broad families of control. Physical controls are the ones you can touch, like fences, gates, turnstiles, and even heating and fire suppression that guard the environment. They shield systems, devices, and facilities directly. A locked server room with a cipher lock is a perfect example. It protects the hardware, and by extension the data and applications that hardware holds. What do logical controls handle instead? Logical controls are the technical protections around information, systems, devices, and applications. They include authentication, authorization, and the permissions that follow. Only someone who can authenticate reaches the data, and permissions decide exactly what they touch. These same controls restrict who can change configuration settings on a router or a server, and they work the same way whether the resource sits on-site or in the cloud. How does all of this tie back to the core triad? Access control exists mainly to prevent loss, and there are 3 losses to prevent. Confidentiality means only authorized subjects reach objects, so an unauthorized read is a loss of confidentiality. Integrity means data and settings are not changed without approval, or that changes get detected, so an unauthorized edit is a loss of integrity. Availability means authorized requests are served in reasonable time, so an outage that blocks legitimate users is a loss of availability. Every control you place is really defending one of these 3. So let's bring it together. Assets are anything of value, tangible or intangible, and the technology set spans information, systems, devices, facilities, applications, and services. You defend them with physical controls you can touch and logical controls built from authentication, authorization, and permissions. And the whole point is to prevent loss of confidentiality, integrity, and availability. Master this map, and every access control decision later in the domain has a clear home. The MCQs covering all the topics and concepts from this session are available on rucloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.